work done by a magnetic field on charged particle is zero. What does it mean? See, when a particle is moving in a magnetic field, charged particle is moving in a magnetic field, the work done by the magnetic field on the charged particle is zero. Let us see how. See, already we have seen force, Lorentz force is equal to Q into V cross producted with the velocity of the charged particle cross producted with the magnetic field, or it means, see, this is the direction of motion of the charge, that is velocity, and this is the direction of magnetic field, and this is the angle between the magnetic field and the charge moving. This is a charge is moving with charge, that is current moving with a velocity v, and the angle between them. See, as it is we have seen by right hand law, V cross V, it means V cross V means from the stretched right hand, from V we will go to B, from V we will fold it to B. It means the thumb comes in this direction. It means the magnetic fold is outward. Outward means like this. This is outward. Outward. See, from here we can see here. This is V. This is V. This is B. V and B. We have seen V and B, and we are moving from V to B. When we lift it up, the force is, we are seeing this way. When we turn it this way, the force will be in the upward direction, because we are moving from V to B. So the force is in the upward direction. Here, when we lift and we keep it in this plane, if these both are in the same plane, the force will be in the magnetic force on this charged particle in this magnetic field will be in the upward direction by the properties of vector field. That means, see here, the force is equal to, force is not equal to a scalar multiplied by V cross B. It means force, the direction, we need not worry about this one for direction. So for direction, it means the direction of force, and force is nothing but vector product of V cross V and B. Therefore, the direction of F is in this direction, because so V cross B, that is V cross B, we go from here to here, is in this direction. We can say it means this is the plane of the V and B. It is kept here. V and B is kept like this. This is the plane, and the force will be in this direction. It means the force, that is Q V cross B, force Fm, that magnetic force is in this direction, that is cross product of V and B is in this direction, and this force is perpendicular with the B as well as this is perpendicular with the Q. See, if you see here, this is perpendicular with the V, and as well as this is perpendicular with the B also. It means we can write here, this is nothing but a vector property. Since magnetic force is perpendicular with the vector V cross B vector. First point. 2. Then magnetic force is perpendicular with the velocity vector V vector. 3rd, magnetic force is perpendicular with the magnetic field. This is nothing but by property of cross product of vectors, cross product of two vectors. So this is, with this factor we are going to take this one only. Now you see, this still all this very simple. This is the plane. Here is V is in this place and Q is in this place. Q here like this, and the vector will be the force. Magnetic force is in this direction. Magnetic force is nothing but cross product of V and B, and this force is perpendicular with V, this force is perpendicular with B. Very simple. If we understand this, then we can proceed very easily. So this is from the magnetic field, like we have this. Now you see what is work done. We must have seen in +1. Work done is equal to dot product of force into displacement. That is a dot product. This is vector. Scalar product of two vectors is a scalar. It means work done is a scalar. That is, we can write F by property its magnitude and cos of angle between them. Now you see here the force here, work done. See, since Fm, see, we can call it as Fm. Fm is perpendicular to V cross V. Fm is perpendicular to V. Fm, that is magnetic force on the charged particle, is perpendicular to B also. It means what is it gives? The angle between what? Angle between magnetic force and velocity vector is 90 degree. This is already proved, because since it is perpendicular from this, it is perpendicular. As 90 degree, that is theta is equal to 90 degree. It means work done is equal to work done by whom? Here this is work done by the magnetic force is equal to force into displacement, because as it is, if a force is applied in this direction and body is displaced in this direction, both has got displacement. It is not distance, displacement. That is, it is vector quantity, and theta is equal to angle between F and S, and F into S. What is the work done? Work done is equal to F dot S, which is equal to F. Thus here theta is equal to 0. Now if we are working, this is the force, it means the velocity also will be in the direction of displacement. This we have seen in the kinematics. When a work displacement is in this direction, velocity will be also be in this direction, because displacement velocity vector is equal to displacement divided by time. It means velocity direction is same as displacement. This already we saw it. It means now here force and velocity both are perpendicular. Force and velocity are perpendicular. It means force, and it means the displacement and force are perpendicular to each other. It means we can conclude displacement here, force and displacement into perpendicular, means the angle between F and S is 90 degree, as cos 90 is equal to 0. Therefore work done by magnetic force is equal to F into S. F into this is it is multiplication. F into 0 is equal to 0. Or we can say work done by magnetic force in a magnetic field on the charged particle is equal to 0. What do you mean by it is equal to 0? Why? It means very simple. Both are, you see, if these two vectors are perpendicular, then dot product of these two vectors is equal to 0. Or if these both are perpendicular, dot product is 0. If two vectors are the necessary condition for two vectors, product and dot product of two vectors to be 0 is both should be at right angles. That is, the theta should be 90 degree. So work done, no work is done. From here, no work is done. By whom? No work is done by the magnetic field on the charged particle. As it is, we have seen work energy theorem. Work energy theorem. What this theorem says, work energy theorem, that is, it is we have seen in the +1 level, that is work power energy, work energy theorem. What it says, that work done is equal to change in kinetic energy. Change in kinetic energy, that is work done is equal to kinetic energy final minus kinetic energy initial. Where kinetic energy, what is the value of kinetic energy? What is the expression for kinetic energy? Kinetic energy is equal to half into mass of the particle into its velocity square. It's kinetic energy. So in this case we can say work done is equal to, since work done is equal to 0, it means work done is equal to 0, kinetic energy also equal to 0. It means what? Kinetic energy final, that is half into mass into final velocity square minus initial velocity, half into mass into initial velocity square is equal to 0. We can take other side out, we can take this side out, or v square is equal to u square. This implies v is equal to u, that is final velocity of the particle is equal to initial velocity of the particle. Final velocity of the particle, it means its velocity does not change. Therefore, speed of charged particle in a magnetic field do not change. Speed of charged particle in a magnetic field do not change, that is, it remains constant according to this condition by work energy theorem also. Velocity remains change means what? The magnetic for it means the velocity does not, if a particle is moving, its velocity is not changing. It means no work is done because velocity is not changing means what? What? Work done. What is work done? Work done is a force into displacement. Then since this is not changing, change in speed is equal to 0. Acceleration, so work done is equal to force into displacement. Force is equal to mass into acceleration into displacement. What is acceleration? See, acceleration is equal to final velocity minus initial velocity by time. So this both are same, this minus this is equal to 0. So acceleration is equal to 0. If the velocity remains same, it means acceleration is equal to 0. The work done is equal to 0. It means we can have three more we can have the conclusions. What we can see two things. When a charged particle is moving in a magnetic field, the work done by the magnetic force on the charged particle is equal to 0. That concludes the final velocity of the particle is equal to initial velocity. Speed does not change. Speed of the particle in the magnetic field, since work done is equal to 0. This becomes but work done is not equal to 0. But what work done is, it means what? The body will move with a constant speed. Constant speed means uniform motion, uniform circular motion. A body moving with uniform speed, not velocity. Velocity means it has got directional property. It's a vector quantity. It moves in a uniform speed. It means uniform speed. A body moving with a uniform speed, but it will vary in direction. See, if in a uniform motion we have seen, and the body is moving with uniform speed. Uniform speed. It means here its velocity is this direction. Draw the tangent. If the body is moving like this in the circular fashion, here is the velocity, but speed remains constant. Speed remains constant. But one thing that we have to see, that is this is also we have seen in the +1 physics. It is an accelerated motion, though speed is not varying, the velocity is changing. Whenever there is a change in velocity, it is an accelerated motion, because acceleration is equal to final velocity in vector form minus initial velocity by time. Speed does not change, but velocity changes. Velocity changes means there is an acceleration. Speed does not change. Speed is a scalar quantity. Velocity is the vector quantity. So we have to conclude that the body moves with constant speed in the magnetic field. A charged particle moves with constant speed, but it changes the direction. The magnetic field changes the direction of the particle only. It changes only the direction of the direction of the charged particle in the magnetic field. Magnetic field does not change the kinetic energy of the particle moving in a magnetic field, but it changes the direction of the particle in the magnetic field. This we have to conclude, because accelerated motion in the uniform circular motion in +1, it goes with uniform speed but with the changing in direction. Changing in the direction means velocity changes at every point, because velocity is calculated at any point when a body undergoes circular motion at the tangent. You take, suppose if it is moving with constant speed, at this point we want to find out the velocity. It means draw a tangent. If the body is moving like this, at this point we want, so this is velocity is changing. Speed, no change, but velocity changes. So we can conclude that the change in direction, the change the direction of the charged particle only occurs here. So this point, speed of the charged particle remains constant, and since the speed is constant, but velocity changes, but the direction of the particle moving in the magnetic field changes.